All right, class. In this video, we continue our discussion of section 6.5 on definite integrals using the U substitution method. And we're going to pick up discussion on page 91 of your note packet. And we are going to use the definite integral to find the average value of a function from between two values of x. Just as we can find the average value of a set of numbers, we can find the average value of a function over from one value of x to another value of x. And the formula that we use to find the average value of a function from x equals a to x equals b is right here. 1 over b minus a times the definite integral from a to b of f of x with respect to x. So let's demonstrate this with a couple of examples. We're going to find the average value of the function f of x equals 2x squared plus 8 from x equals 0 to x equals 3. In this case, a is equal to 0 and b is equal to 3. Now, I have taken the liberty of graphing that function for you. F of x equals 2x squared plus 8 from x equals 0 to x equals 3. And you can see the minimum value of the function is 8 on this interval, and the maximum value of the function is 26. You would be in error if you took the minimum value and the maximum value and averaged them to get the average value of the function. That 8 plus 26 is 34, and 34 divided by 2 is 17. So the average value of 8 and 26 is 17, but that's not the average value of the function. So you would be in error if you just took the minimum value of the function and the maximum value of the function and averaged those two numbers. So using the formula up here, we plug in for a, b, and f of x, and we see that the average value of the function on that interval is 1 over 3 minus 0 times the definite integral from 0 to 3 of 2x squared plus 8 with respect to x. Now, we don't have to use the U substitution method here. We can just use the basic rules of antidifferentiation. 1 over 3 minus 0 is 1/3. The antiderivative of 2x squared is 2/3 times x cubed, and the antiderivative plus 8 is 8x. And the limits of integration are 0 and 3. So now we plug in the upper limit of integration in for x, and we have 1/3 times the quantity 2/3 times 3 cubed plus 8 times 3. Then we subtract and put in the lower limit of integration, and we have minus 1/3 times the quantity 2/3 times 0 cubed plus 8 times 0. Well, this in parentheses is just equal to 0, right? This first term is going to equal 0. This term is going to equal 0. 0 plus 0 is 0. Minus 1/3 times 0 is 0. So the average value is just solve this arithmetic expression right here. And the value of that arithmetic expression is 14. So the average value of the function f of x from x equals 0 to 3 is equal to 14. And when we average the minimum value and the maximum value of the function over here, we got 17. So we just showed that that would be a mistake to do that. The actual average value of the function from x equals 0 to x equals 3 is 14. All right, so now let's take a look at the next example. We're going to find the average value of f of x equal to square root of 3x plus 10 from x equals minus 2 to x equals plus 2. A is equal to minus 2, b is equal to plus 2. So plugging into the average value formula, the average value is equal to 1 over 2 minus a negative 2 times the definite integral from minus 2 to plus 2 of the square root of 3x plus 10 with respect to x. Now in this problem, we got to use the U substitution method. We set u equal to 3x plus 10 under the radical. Then the derivative of u with respect to x is 3. And when we multiply both sides by dx, we get du is equal to 3 dx. Well, we have the dx, we don't have the 3. So we divide both sides by 3 and we get 1/3 du is equal to dx. So 1 over 2 minus a negative 2 is equal to 1/4. And then we can replace 3x plus 10 on the radical with u, and we have the square root of u. And then we replace dx with 1/3 du. And so our radicand, we take the definite integral, square root of u times 1/3 with respect to u. Now we got to change the limits of integration for the variable u using our equation u equals 3x plus 10. When we put in minus 2 in for x, we have 3 times the negative 2 plus 10, which is 4. And when we put in plus 2 in for x, we have u is equal to 3 times 2 plus 10, which is 16. So our limits of integration go from minus 2 to 2 to 4 to 16 with the variable substitution. The 1/3 can be brought out from the definite from the integral sign. So we have 1/4 times 1/3, which is 1/12. And you know square root of u, it can be written as u to the 1/2 power with a rational exponent. Well, the antiderivative of u to the 1/2, right? If you add 1 to the exponent, 1/2 plus 1 is 3/2, and then you divide by 3/2, which is the same as multiplying by 2/3. So we have 1/12 times 2/3, which simplifies to 1/18. So when we put in the upper limit of integration 16 in for u, we have 1/18 times 16 to the 3/2, and then we subtract and put in the lower limit of integration for u, and we have minus 1/18 times 4 to the 3/2, and when you do that arithmetic, you get 28/9 is the average value of the function f of x from x equals minus 2 to 2. 28/9 is the average value as an improper fraction.